Voyager, the odyssey of our interstellar pioneers. In 1977, NASA embarked on one of the most ambitious space missions ever attempted. Two spacecraft, each roughly the size of a Honda Civic, were carefully loaded onto a single rocket and set on a 5-year mission to explore the outer planets of our solar system. These twin spacecraft, later known as Voyager 1 and Voyager 2, would become humanity's emissaries into the far reaches of space, unraveling secrets about planets, moons, and the very edge of our solar neighborhood. A rare alignment and a grand opportunity. The seeds of this audacious mission were sown during a rare cosmic event. In the late 1970s, the solar system experienced an extraordinary planetary alignment, an arrangement that occurs only once every 175 years, where the gas giants Jupiter, Saturn, Uranus, and Neptune lined up on one side of the Sun. This alignment created an unparalleled opportunity for scientists to study these distant worlds using a single mission. Seizing the moment, NASA launched Voyager 2 on August 20, 1977, followed shortly by Voyager 1 on September 5, 1977. Despite launching nearly 2 weeks later, Voyager 1 was designed to travel on a faster trajectory. As a result, it quickly overtook Voyager 2, reaching speeds of about 38,000 miles per hour compared to Voyager 2's 34,360 miles per hour. This extra burst of velocity allowed Voyager 1 to capture one of the mission's earliest iconic moments. Just 13 days after its launch, the spacecraft snapped a historic image of Earth and its moon from a staggering distance of 7.2 million miles, a powerful symbol marking the beginning of its epic journey through space. The early triumphs, Jupiter and its mysteries. Voyager's journey through the outer solar system was filled with groundbreaking discoveries that forever changed our understanding of the planets. Both spacecraft made their way to Jupiter, arriving in 1979. As they approached the giant planet, they provided humanity with our first close-up views of its swirling atmosphere and its complex system of rings. Among their many findings, the Voyagers uncovered 3 previously unknown moons orbiting Jupiter. One of the most significant discoveries was that of Ganymede. Prior to Voyager's arrival, Saturn's Titan was considered the largest moon in the solar system. However, data from Jupiter revealed that Ganymede is even larger, shattering previous assumptions. Additionally, the probes delivered unprecedented images of Europa, whose smooth, ice-covered surface is marked by intriguing cracks. These observations have since sparked scientific theories suggesting the existence of a hidden subsurface ocean, an idea that continues to drive further exploration and study. Another highlight of the Jupiter encounter was the first detailed observation of the Great Red Spot, a massive centuries-old storm larger than the entire Earth. This swirling vortex, a defining characteristic of the gas giant, offered scientists a glimpse into the complex atmospheric dynamics of Jupiter, setting the stage for more ambitious discoveries later in the mission. Saturn, a turning point in the Voyager mission. After the success at Jupiter, the Voyagers set their sights on Saturn. The approach to Saturn marked a pivotal phase in the mission. Initially, NASA's plan was to explore only Jupiter and Saturn over a 4-year period, but the trajectories were designed with the possibility of extending the mission to include further planetary encounters. For Voyager 1, a critical maneuver came with its close encounter with Titan, the only moon in the solar system with a thick, dense atmosphere. Titan's mysterious atmosphere concealed its surface from optical instruments, preventing scientists from uncovering its secrets immediately. However, the spacecraft's flyby provided tantalizing clues about Titan's environment. The data indicated that Titan's temperature was near the triple point of methane, a state where this compound behaves similarly to water on Earth, offering hints about possible exotic meteorological processes taking place on this distant world. Saturn itself was revealed to be a world of breathtaking beauty. Detailed images of the planet's rings showed that they are composed of hundreds of finely structured, narrow bands. In addition to mapping the intricate rings, the Voyagers identified 4 new moons orbiting Saturn. Among these, Mimas drew particular attention due to the enormous Herschel crater that gave it an uncanny resemblance to the iconic Death Star from science fiction lore. Diverging paths, Voyager 2's exploration of the ice giants. While Voyager 1's course was dramatically altered by the gravity of Saturn, redirecting it on a path that would eventually lead out of the solar system, Voyager 2 was set on a trajectory that would take it even deeper into uncharted territory. After its Saturn encounter, Voyager 2 ventured toward Uranus, arriving in January 1986. This encounter brought to light a planet that was strikingly different from both Jupiter and Saturn. Uranus presented a surprising composition. While the gas giants are largely made up of hydrogen and helium, Uranus was found to harbor these elements only in its outer atmosphere. Beneath that tenuous layer complex interior composed of water, ammonia, methane, and hydrogen sulfide, with a solid core of rock and ice. The discovery of these unique characteristics led scientists to classify Uranus, and later Neptune, as ice giants, a distinct category that has since deepened our understanding of planetary formation and evolution. Voyager 2's journey did not stop with Uranus. Its final major planetary target was Neptune, the eighth and farthest planet in our solar system. In August 1989, Voyager 2 became the only spacecraft to fly by Neptune, capturing the first detailed images of this distant world. Although Neptune appeared a vivid blue in the photographs, subsequent data analysis revealed that its true color is closer to a teal hue. The flyby of Neptune completed Voyager 2's grand tour of the solar system's outer planets, leaving behind a legacy of detailed maps, spectral analyses, and countless mysteries yet to be fully understood. Venturing into the unknown, entering interstellar space. After completing their historic flybys of the gas and ice giants, the Voyagers continued their journeys outward, eventually reaching the boundaries of the Sun's influence. For more than a decade and a half, the spacecraft drifted in a region of relative calm before an extraordinary event on August 25, 2012, signaled a dramatic transition for Voyager 1. The spacecraft's instruments detected a sudden drop in the charged particles originating from the Sun, coupled with a significant increase in the levels of galactic cosmic rays, high-energy particles from beyond our solar system. This indicated that Voyager 1 had passed the heliopause, the outer edge of the solar wind's domain, and had entered interstellar space. Voyager 2 would follow suit by crossing this boundary in November 2018. The heliopause is the point where the Sun's solar wind is no longer dominant, giving way to the interstellar medium, a space filled with particles and magnetic fields from the galaxy at large. In essence, these milestones signified that the Voyagers had ventured beyond the protective bubble of our solar system, entering a realm where the influences of the Sun are minimal, and the vastness of the Milky Way begins in earnest. The legacy of Voyager. Throughout their journey, Voyager 1 and Voyager 2 have provided humanity with an unprecedented window into the workings of the solar system. The observations from Jupiter, Saturn, Uranus, and Neptune have not only enriched our understanding of these celestial bodies but have also raised profound questions about the nature of our own planet and our place in the cosmos. One of the enduring legacies of the Voyager missions is the iconic, pale blue dot image, captured by Voyager 1 on February 14, 1990. From a distance of 3.72 billion miles, Earth appeared as a tiny, almost imperceptible dot, just 0.12 pixels in size, floating in the vast darkness of space. This image has come to symbolize the fragility and isolation of our home planet, inspiring both awe and introspection about the nature of existence in an expansive universe. Even now, decades after their launch, the Voyager spacecraft continue to transmit data from the depths of interstellar space, carrying humanity's message to the cosmos, a testament to human curiosity, perseverance, and the unyielding spirit of exploration.